In Chapter 8, Section 4, we learned something called synthetic division, which can, on times, replace long division. So example 0, for fun, rather than example 1. Let's take 3x to the third minus 4x squared minus 3x minus 2 divided by x minus 3. Now, we could have done this in long division in our lesson on Section 3. What makes synthetic division possible is that our divisor has a couple of characteristics. First of all, that it's x, or whatever variable, to the first power, and then some constant, so plus or minus something. If we have a coefficient other than 1, we'll have to take that into account. But it works nice and easy when we have a coefficient of 1, x to the first power, and then plus or minus some constant. If we have that, then our shortcut, synthetic division is a shortcut here, we'll start by just writing the coefficients of our dividend. Just the 3, the negative 4, the negative 3x, the negative 2. But be careful for placeholders here as well. So I've got the x cubed, x squared, x to the first constant taken care of. And then what we're going to do is leave room for a row of numbers. Draw a line between these last two coefficients. Draw another line perpendicular. Everything below this line to the left will be the coefficients of my quotient. And everything to the right of this would be my remainder. Now, we haven't taken our divisor into account yet, so we write like an upside down division sign. And if we have 1x to the first power, then we can take the opposite of this constant. So instead of negative 3, positive 3. Now, you might wonder why we're taking the opposite. Well, as you watch this process unfold, we're doing pretty much the opposite operations that we did in division, which was subtraction and dividing. Here we're going to multiply and add. So we take the opposite sign. That lets us do some opposite operations. The first step is always take down this first coefficient, write it down below the line. That first coefficient is called the leading coefficient. So don't change it, just write it below the line. Then from here on out, everything's pretty much repeating what I'm about to say. And that's the number you just wrote below the line. Multiply it by the 3 that's in the multiplier box. Put it in the next column, and then we're going to add those two results. Okay, so whatever number this is, c, I'm going to say let's multiply that number times c and put it in the next column. Now we're going to add. So negative 4 plus 9 is 5. Now we're going to take the number we just wrote below the line, multiply it by the c, the number in our multiplier box, put it in the next column, and add. Negative 3 plus 15 is 12. Again, the words will sound familiar. Take the number you just wrote below the line, multiply it by the c, or the number in my multiplier box, put it in the next column, so 3 times 12 is 36, and add those results together. Negative 2 and 36 is 34. So 3, 5, and 12 represent the coefficients of my quotient. 34 represents my remainder. Let's actually put all the pieces together here. And if we start at this line, work our way right to left. This would be my constant. That would be x to the first. That would be x to the second. And if we had more numbers, x to the third, x to the fourth, etc. So my quotient is 3x squared. And since they're all positive here, it's addition signs. Plus 5x plus 12 plus my remainder, 34, over my original divisor, x minus 3. So there's my quotient and remainder, and a process known as synthetic division. And I took a lot of time to explain that, but as we look at some of the other examples coming up, you'll see that this is much quicker, much faster than the process known as long division. So let's look at another example, example 1 this time. I'm going to take 2x to the third plus x squared, careful, no x to the first, plus 12 divided by my divisor, x plus 2. So I start by taking the coefficients of my dividend, 2x to the third, positive 1x squared, and yep, don't forget the placeholder, 0 for x to the first, 12 for the constant. If you forget this placeholder, we'll not get the right answer. My divisor is 1x to the first power, so we're good for synthetic division. And we take the opposite of this number, positive 2, turn it into negative 2. So that's my little number c, or what I call the number in my multiplier box. Leave room for a row of numbers, draw a line, draw another line perpendicular to that between the right two numbers of my dividend, Everything to the left represents my quotient. Everything to the right represents my remainder. And we start by bringing the first number down. Just take the 2, write it below the line. 2 times negative 2 then goes in the next column, which is negative 4. 1 plus negative 4 is negative 3. Negative 3 times negative 2 is positive 6. That goes in the next column. 0 plus 6 is 6. 6 times negative 2 is negative 12. That goes in the next column. And we add to get a remainder of 0, which means that my divisor divides evenly into my dividend. Well, let's pick up the rest of the quotient here. To the left of this line, separating the quotient from the remainder, we go from right to left. First number is my constant, x to the first, x to the second. And if there are any other numbers, x to the third, x to the fourth. So that's my quotient, 2x to the second minus 3x to the first plus 6. Now some of you are wondering, well, is it okay that we got x squared? It's not only okay, but it's essential. Because if you think about it, we started out with an x to the third divided by an x to the first. So my largest exponent in my quotient should be x squared. And it divided evenly, which is nice to know. Hopefully you can see the benefit and speed of dividing using synthetic division instead of the long division process. So let's move on to example 2. Again, watch out for those placeholders. I've got 2t to the 5th, negative 3t to the 4th, negative 50t to the 3rd, negative 24t squared. We don't have a t to the first power, so I must have a 0. And I don't have a constant, so I need another placeholder of 0. So those two zeros are as important as having 100 versus having 1. Need the placeholder for t to the first power, my variable of the first power, and a constant. And then we are dividing by the dividend, which is 1t to the first, so that's good for synthetic division. We'll take the opposite of negative 6, which is positive 6. Leave room for a row of numbers because we're going to multiply and add. Draw a line. Draw another line perpendicular between the last two coefficients, placeholders in this case, of my dividend. Everything to the left here will be my quotient. Everything to the right will be my remainder. And we start, just like we always start, with synthetic division. And that is by taking the leading coefficient and writing it below the line. So 2. From there, everything is multiplying the number we just wrote below the line times this constant. Put that product in the next column, add the two results. So we'll just repeat that process. 6 times 2 is 12. Put in the next column and add. Negative 3 plus 12 is 9. The number just below the line, 9 times 6 is 54. Put that in the next column. Add negative 50 to positive 54 to get 4. 4 times 6, well, that's positive 24. Add negative 24 and positive 24 to get 0. 0 times anything, including 6, is 0. And 0 plus 0 is 0. 0 times anything again, 6 is 0. Put that in the next column and add, and 0 is my remainder, meaning it divides evenly. If you didn't have the placeholders, you would not get the correct coefficients. So let's fill them in for our quotients. No remainder, so that's my constant. That's t to the first, going left, t to the second, then t to the third, then t to the fourth. All the positives I can turn into addition. And we should just double check. Yep, t to the fifth divided by something t to the first should give us a quotient with t to the fourth. So my answer is, my quotient is 2t to the fourth plus 9t to the third plus 4t squared. And we don't need to write those placeholders anymore now that we finished. Alright, so in the next example, the question occurs, well, I still have x to the first power, but it's not 1x to the first power. What do we do? Well, let's take a look. 2 is not the greatest common factor, but whatever this number is, let's factor it out. So 2x divided by 2 is 1x. Negative 1 divided by 2 is negative 1/2. Now I'm going to keep this 2 on hold for a second and pretend my divisor is x minus 1/2. But don't lose that 2. We're going to come back to it. So for my divisor, instead of x minus 1/2, I'm going to take the opposite, call that positive 1/2. For my dividend, I've got 4x to the third, and nope, there's no x squared term, so I need a placeholder for 0x squared, 1x to the first, and negative 1. Leave room for a row of numbers, draw the line. Between the last two coefficients, draw a perpendicular line. Everything to the left is quotient, everything to the right is remainder. And we start by bringing down the leading coefficient, which is 4. 4 times a half, well, we can handle that. That's 2. 0 plus 2 is 2. Sorry, I was doing the next step in my head. 0 plus 2 is 2. 2 times a half, that's where that 1 comes in. 1 plus the 1, well, that's 2. 2 times a half again is 1, so we multiply, put that in the next column, and add. Negative 1 plus 1 gives us a remainder of 0. Now, be careful, that's not quite my quotient. We divided by x minus a half. We'd factored out a 2. So what I need to do to all of my coefficients of my quotient is to divide them by the 2 that I had factored out. Divide them by that 2. That's why we weren't supposed to lose that 2. So that gives me coefficients of 2, 1, and 1. So for my quotients, my constant is 1, x to the first, x squared. If they're positive, put plus signs in there. And yes, just to double check, something x to the third divided by x to the first should be x squared. So my quotient is 2x squared plus x plus 1. Now you say, why didn't I divide 0 by 2? Well, there's no point, 0 divided by anything. And of course, if there's no remainder, I don't need to write anything down for a remainder. But that leads us to the next example. So let's take a look at example 4. And set this up with synthetic division. I still have x to the first. My divisor is a binomial. I don't have a coefficient of 1. So again, whatever that coefficient is, which coincidentally it just turned out to be 2, factor it out. 2x divided by 2 is x. 3 divided by 2 is 3/2. My dividend is 6x to the third, 7x squared, 1x, 1. Leave room for row numbers, draw a line. Between the last two coefficients, draw a perpendicular line. Everything to the left represents my quotient. Everything to the right, my remainder. And I'm going to pretend I'm dividing by what's in parentheses here because it does have a coefficient of 1 and it is x to the first. So I'll take the opposite of 3/2 and make that negative 3/2. Now I know you love fractions, but let's start by bringing down the leading coefficient. 6 times negative 3/2. Well, 2 divides into 6 3 times. Times negative 3 is negative 9. Put that in the next column and add. 7 plus negative 9 is negative 2. Multiplying 3 over 2 times 2 over 1. The 2's cancel out. Negative 3 times negative 1 is positive 3. Put that in the next column and add. 1 plus 3 is 4. 4 times negative 3/2. Well, 2 will divide into 4 2 times. 2 times negative 3 is negative 6. Put that in the next column and add, and we get negative 5. Doesn't divide evenly. But be careful because those coefficients aren't the numbers that represent my quotient. We have the 2 here. Let's divide all the coefficients of my quotient by 2. So doing that, 6 divided by 2 is 3, negative 2 divided by 2 is negative 1, 4 divided by 2 is 2. And if we fill in, that's my constant, x to the first, x squared. Now, I know some of you are worried about this remainder. Are we going to divide it by 2 or not? Well, no need in this case. I'm going to take my remainder, negative 5, and as long as I put it over my original divisor, 2x plus 3, no need to divide that by 2. So my quotient then is 3x squared minus x plus 2 plus my remainder negative 5 over my original divisor 2x plus 3. And that's our look at synthetic division.